Let us learn how to solve these type of problems. The, as you know, this is about the resistance, and the resistance are connected in different ways, and you have to find the net resistance between this point A and B. Here also you have to find the unknown resistance. So let us see, first of all, let us see what resistance is, as we can categorize materials into three, like conductors, insulators and semiconductors. And the conductors are the one which allows a free flow of electrons through it, or free flow of electricity through it, and insulators are those which does not allow the electricity to pass through it, and semiconductors are those which partially allow. That means you can actually control the flow of electricity through it. So when you take the case of a conductor, the conductors can be categorized as good conductors and bad conductors depending upon how much they are able to allow, allow the passage of electricity through it. For example, if you take gold and silver compared to copper, they are good conductors because they provide less resistance or hindrance. So hope you understood what the resistance is. It is a hindrance which is provided to the flow of electrons. Now this resistance depends upon, as it is denoted by the letter R, depends upon few factors like how long the conductor is. So as the length increases, the resistance value also increases. Length increases, the resistance value also increases. If the area of cross section, how much wider the path is, if the area of cross section increases, the resistance value decreases. And temperature, if the temperature increases for a conductor, then the resistance value also increases. In brief, I can say, see, the length increases means the electron has to pass a greater length, so it will come across more number of ions which are vibrating or which can produce hindrance in its path. So as the length increases, so they are prone to have more hindrances in their path, so the resistance increases. Similarly, if the area increases means they have a wider path, so then the path is not constricted, so it is a wider path, so they can flow much more freely than a narrower path. So as the area increases, the resistance will decrease. Now when the temperature increases, those who are providing this or producing this hindrance by vibrating themselves, actually when the temperature was low, few of them may be silent, few of them may be not vigorous at that moment, but as the temperature increases, they start to vibrate more and more, so the electrons which are passing will feel more hindrances now. So as the temperature increases, the resistance value also increases. Now coming back to these sort of problems, so hope you understood what the resistance is, how it varies. So you have a formula like this: R is equal to rho times L by A. Now in this, this length, L denotes the length, A denotes the area of cross section of the conductor, and R is the resistance. Then what is this rho? Something like P. So rho is what you call as the resistivity. See, resistivity means the resistance offered by the a conductor of unit length and unit area of cross section. So if I take the same conductor and I take a unit length and unit area of cross section, the resistance offered by that part is what I mean by the resistivity. And the resistivity of a conductor of a given material remains constant till the temperature is remaining constant. So it means that is something like a standard value. At a given temperature, you have a particular resistivity value for a given material, and the resistance varies as the length and area varies. So I hope you understood what resistivity is and what resistance is. Now let us come to these sort of problems where the resistors are connected. Normally they are shown by this kink like thing. So the value will be written somewhere here. So if it is 12 ohms, so 12 ohms is the resistance which is provided by this part. Now when you connect these resistors back to back, something like this, 12 ohms, another 12 ohm back to back. So when I connect them back to back, I call it as series connection. And if the same resistors are connected something like this, its front end is connected together and its back end is connected together, you call it as parallel connection. Now when you connect the resistors in series, the net resistance will simply add up. So in this case the net resistance is 12 plus 12, that is 24 ohms. But in this case, let it be 2 ohms and let this also be 2 ohms. So when you connect them in parallel, the net resistance is something like this: 1 by R parallel, which is the net resistance in parallel, equal to 1 by R1 plus 1 by R2, that is 1 by 2 plus 1 by 2, that is 1, and resistance in parallel will be equal to 1 by 1, which is 1. So actually when you connect the resistors in parallel, you have to find the reciprocal value and of the resistors. So the net resistance when the resistors are connected in parallel, the net value actually decreases, or it will be lesser than the smallest resistance which you connect in the circuit. That's one way to find out whether the answer which you have found is right or wrong. If you have resistors in parallel and you get the resultant value, you check whether that value which you have got is lesser than the smallest value in the circuit. If it is not, then your answer is wrong. Now when you connect resistors in series, the net resistance increases. When you connect the resistors in parallel, the net resistance decreases. Now you have a combination of all these in a normal circuit which is given, which is they ask for the examiner. See in this case, when you connect the resistors in series, the same current flows through both the resistors. So if I is the current entering the circuit, let this resistor is connected to a battery. If I is the current entering the circuit, the same current flows to this R1 and R2. But when the resistors are connected in parallel, something like this, and let this be R1 and let this R2 connected to a battery, so I current flows. Now current has got two options. It can flow this way and also it can flow this way. So we can't argue that the same current flows through R1 and R2. It depends upon the resistance value. The circuit whose resistance value is more, the current will be less because the resistance is hindrance. So hindrance more means the flow of current will be less, flow of charges will be less. So in parallel is not the same current which is flowing through each resistor, but in series is the same current which flows through both of the resistors. Now come back to this sort of circuits. In this case, you can assume whenever you try to solve this sort of problem, let us see who is in series and who is in parallel first. For example, a current enters from this end A. Now when the current reaches here, it has got two paths. It can travel to this path and it can also travel to this path. So whenever the current feels two paths to travel, then just keep in mind that from there onwards it is parallel circuit, because the current has got two paths. So one way like this, and through the 1 ohm, then through the 2 ohm, then through the 3 ohm, and another way like this, directly to the 3 ohm. So this branch and this one are in parallel to each other. Why? Because current reaches here, current finds two paths. So those paths through which the current gets divided, those two paths are parallel to each other. Now how to solve this sort of, now we understood which is series and which is parallel, because current enters this, then it has got two parallel paths, then again reaches here, then again pass through this. So you can draw this figure something like this. It enters the 3 ohms, then it has got two paths. In one path you have this 1 ohm resistance, 2 ohm resistance, then it has another 3 ohm resistance, then reaches this junction, and it has got another path from here, that is this 3 ohm resistance, and it also reaches the same junction. From there you have another 3 ohm resistance and reaches B. Hope you understood this way. I just extended this end. So current enters the 3 ohm resistance, then it passes through this 1 ohm, then it passes through the 2 ohm, then it passes through the 3 ohm. That is one path. The same current has got another path to travel through, that is this 3 ohm resistance. The currents get divided, and again current joins to form the same old current. Now once you understand this, then you can easily solve. You start by solving the one who are in parallel, like this box completely is in parallel, so you have to solve this sort of circuit first. See, this 1 ohm, 2 ohm and 3 ohm are back to back connection. So 1, 2 and 3 back to back means series, so obviously the 3 can be considered as they are in parallel, so you can substitute with a one single resistance having the value of all the 3. So since they are in series the resistance adds up, so 1 ohm added to 2 ohm added to 3 ohm, so that is 6 ohms. So you can substitute by a 6 ohm resistance here. Now you can see the 6 ohm and 3 ohm are parallel to each other because the same ends are meeting at this end and the back end is meeting at the other, so these two are parallel. So then you solve this, so that it will be 1 by R parallel equals 1 by 6 plus 1 by 3. You can cross multiply 3 plus 6 by 18, that is 1 by Rp. So you have 9 by 18 equal to 1 by Rp, and resistance in parallel equals 18 by 9, which is 2 ohms. So this 6 and 3 can be substituted by a 2 ohm resistor. So let me have this part and let me substitute it by a 2 ohm resistor. Now see, this 3, 2 and 3, the current has only single path, means that all the 3 are in series. So 3 plus 2 plus 3, so 5 plus 3, that is 8 ohms. So the net resistance between A and B is 8 ohms. Hope you understood. You just think when you pass through each resistor and when you reach any junction, see whether the current is getting divided or not. If it is getting divided, it means that path is becoming parallel to each other. So first you solve them, substitute by the single value, and finally make them in a series circuit. That is how you have to solve this type of problems. Now let us see this problem also. Here you can see the current reaches here, gets divided into two paths. So obviously this path and this path are parallel to each other, and this 7 ohm is back to back with 5 ohm, so these are in series. So first you solve that. So you have this 2 ohms and unknown resistance x ohm connected here. I don't know what this value is. The question is to find this x, and you have this 7 and 5. So let me substitute this 7 and 5. This is my point B. So let me substitute this 7 and 5 with a single resistance. Now since they are in series, this 7 and 5 can be substituted by single resistance of the summation. The 7 plus 5 is 12. So you have a 12 ohm resistor here. Now they have given the net resistance felt, or the resultant of this value between A and B, resultant resistance between A and B is 4 ohms. So what does it mean? When you solve this and then you find the parallel resistance of both, then you will get 4 ohms. Means, so these two are back to back, so they are in series. So I can substitute it by a single resistance whose value is 2 plus x. Instead of writing two figures, I can substitute it by a single value. That is, here it is 2, here it is x, so I can write it as 2 plus x. Now this 2 plus x is in parallel with 12 ohms. So means 1 by Rp is equal to 1 by 2 plus x plus 1 by 12. And they have said the net resistance, that is the Rp in this case, the resistance between A and B is 4 ohms. So I can substitute for Rp as 4 ohms. Hope you understood why I am substituting for as 4 ohms, because they have said the resistance between A and B is 4 ohms. So when you solve this, that is the resistance in parallel, these two, then you will be getting 4 ohms. So I can write it as 1 by 4 equals 1 by 2 plus x plus 1 by 12. Now many will don't write it somewhere like I have seen some answer papers, something like this, all are in denominator. Some will write it as 4 is equal to 2 plus x plus 12. So in mathematics such things are not allowed. Now how you solve, so you cross multiply 12 plus 2 plus x divided by 12 into 2 plus x, you multiply like this and then multiply the denominators, you will get it as 1 by 4. So 12 plus 2 plus x, so that will become 12 plus 2 plus x divided by 12 into 2 plus x, which will give us the 1 by 4. So this will be 14 plus x divided by 24 plus 12x equals 1 by 4. Now you cross multiply again, that will be 24 plus 12x equals 14 into 4 plus 4x. So you have 24 plus 12x equals 56 plus 4x. And you take it to this side and the other one to the other side. So you have 12x minus 4x equals 56 minus 24, that will be equal to 32, and you have 8x here. So x will be equal to 32 by 8, which is equal to 4 ohms. This is how you have to solve this sort of problems. First of all, check who all are in series, who all are in parallel. Then already the net resistance is given, and you continue using the formula for the parallel resistance, and finally you will get the value for the net resistance. You substitute the net resistance value, then you will get the unknown resistance value. Only thing is, you should be clear about which all resistors are in series and which all resistors are in parallel. And easiest way to find out is you just check whether the same current is flowing through them, or in between is the current getting separated, and if it is getting separated, then those two paths are parallel to each other. Hope you understood this. Thank you.